Now, before going to the new concepts, the limit of a function, suppose we consider this example. Suppose we are given the function f of x is x squared minus x plus 2. And the graph of this function is shown here, the blue one. Okay. And they say that, okay, investigate the values when x is near 2. Okay. So in the graph, x is equal to 2 is right here at this position. Then the value of this, according to this formula, will be this number right here. The value in the y, we substitute this, or we can compute it. 2 squared minus 2 plus 2 give us 4, right? Now, take a look at the points near 2. So what is the value of the function f of x when x is equal to 1? Wow, so fast. 1 squared minus 1 plus 2. Yes, it is 2. Good job. Use your calculator to compute the value when x is equal to 1.5 here. What is it? 2.75. Good job. How about others? Do you find the same result? Very good. So, or we can use fraction, right? 1.5 is 3 over 2. Then we substitute the value of this 3 over 2 to this function. We have 3 over 2 all square minus 3 over 2 according to this formula plus 2. And 3 over 2, remember the fraction 3 over 2 square, it means that it will be 3 over 2 times 3 over 2. Therefore, it is, what is it? 9 over 4. Very good. We got it here, right? But remember, yesterday we discussed this. We cannot add a whole number and a fraction. We can only do so when they have the same denominator. That is why we manipulate this. And here the second number is 3 over 2. We see that they have 4 is the common denominator. That is why, oops. That is why I manipulate we multiply by 2 in the numerator and divide it by 2. It doesn't change this fraction, right? And here 2, we can write it as 2 times 4 and then divide it by 4. It doesn't change anything. But now they have the same denominator. Then we can add and subtract the numerator together. So we keep, oh, sorry, this should be 4. They have the same denominator 4, right? And the numerator here is 9 minus 3 times 2 is 6, and then plus 2 times 4 is 8. Then finally, what do we have here? Very good. 11 over 4, right? And 11 over 4 will be 2.75. This is another way. Good job. Okay. Now, how about the value when x is equal to 1.999 here? I believe, yes, 997. Very good. Who was it? Very fast. Thank you. 997,001. Okay. And similarly, at 3, we have 8 At 2.5, it would be 5.75, right? Now look at these numbers. Here, from 1 to up to 1.9999, it means that in the graph here, it approached from the left side of the number 2 here, right? See it? And the values will in the y direction, it will be from 2 to 3.4, 3.7, and up to 3.999, something here, very close right here. And the second column here are the values when x approach 2 from the right-hand side, it reduced from 3 to 2 here. And the value reduced from 8 to 4 here, right? So, or we can see in the graph here, when x approach 2 from the left-hand side, the function, the curve, approach the value from this value going up here and reach number 4 here, right? And when it x approach 2 from the right-hand side, the value will go down to this direction and reach number 4. So that is why we have the concepts. We call the definition of this. We call that the limit. Simply say that n notation for this would be like this. And we say it, the limit of the function fx is x approaches a equal to L, right? In the previous example, it would be limit of f of x when x approaches 2, and what was it? Yes, 4, and it is right here, right? So mathematicians are lazy, so they create new concepts, so they don't have to write many things, many letters, right? So it's good. Or we can say this, fx approaches L is x approaches A, like this one. There are 2 ways to say it and write this. Okay? Very new concepts, but very useful. But remember, x is not equal to A. X is different from A. Very important. It does not necessarily be defined. It could be undefined at A. Okay? A, good. A is simply a number, given number, we consider. In this case, yeah, in the previous example, it is 2. Very good. L is the value fx approach 2, and in the previous example, L is, what is it? Very good. L is 4 in this case. Yeah, L is 4. And or we can write this. This is L, and this is A in this notation. Okay? Yes. A is the value in the x-axis, and L is in the y-axis. Very good. A belongs to the OX axis, L belongs to the OY axis. Okay? Is it clear? Very good. And here are some more examples. Look at this. The first one. Suppose we are given the curve, the blue lines here. Okay? And the value A we are considering is at this point, and L is at this point. We see that according to the curve here, for any value here on the left side of A, then suppose this is the function f of x, then f of this point will be the line it cut the curve it is this point, and the value of this will be here. We see that if x0 approaches a here, then this value right here is f of x0. It will approaches L from below. Okay, I go this way. Seem to be. Is it good? And how about if x approaches a from the right hand side? Then we can find the value. Suppose this is x1, then the vertical line going through x1, it cut the curve at any point here, and then from that point we project to the y-axis. It will give us the value f of x1 in this y-coordinate. Okay, we project. So as we see that x1 come closer to a from the right hand side, f of x1 will come closer to L this way. Okay. And one more thing, very important. Here, at this point, at x is equal to 0, the line is a solid line. So this implies that f of a is equal to L in this case. However, the graph here on the right hand side, there's a hole right here. Do you see it? It means that the function at this point, and there's a dot here, this implies that the function value f at a is equal to this dot, and let us call m. M is any number right here. It's random. Let us call it this way. Okay. This is how we draw a graph. And it is defined at this point. But we see that when x approaches a from the left-hand side, f of x approach, it will be this point here, right? It will go to this and approach to this value of L, right, in the y direction. And the limit of f of x when x approaches a is always equal to L in these two cases here. And in the first case, f of a is equal to L. In the second case here, f of a is equal to the value of this solid point. Let us call it M in this case. And in the third case, the similar things. F of a, we see that there's no dot, but there's a hole at this point. This implies that f of a is not defined. Just some notation. But the limit of all these functions are the same. It is equal to L. Is it clear about limit now? Try to memorize these graphs. It helps a lot. Okay. Yes. Sorry. The value of the function at a is defined in the first case. In the second case, the value of the function is not equal to L. it is below this, right? In the third case, f of a is not defined. It's not really clear, okay? Because we see that there's a hole right here. So, m is a number I made it up. Yeah, because we know it is here at the position and it doesn't give us a number. So I call it n. You can call it anything. Oh, just a notation. In math, if we draw a graph and the hole here, it means imply that at that value it's not defined. Okay? The curve only contains this, and then it is cut here, and then it continues. The L is a number, a given number function. Sorry? Yes. Even when you see that the limit of all these functions is L, but it could be undefined, or it could be defined by a different number, or it is defined at the same value. I know it's a little confusing at first, but is the concept clear now? Very good. Let me think if we can. So here is the table of the previous function. Now, let us take a look at this example very quickly. Example 1. If we are given the function f of x is x minus 1 divided by x squared minus 1 here. We are given that the graph here is this blue line here. At 1, what is the value of the function? What is f of 1? Interesting. F of 1 will be 1 minus 1 according to that definition here, right? Divided by what? 1 squared minus 1, it is undefined, right? Fraction is not, if the denominator is equal to 0, then it is undefined. We don't know what it is undefined. Remember? Very good. That is why you see that here, the value of is equal to 1. There's a hole right here of the graph. Okay? The function is not defined at 1. Very good. Now, compute the value of the function here at x is equal to 1/2. What is it? Two over 3. Very good. This is 2 over 3. But they say that, okay, write it in 6 decimal places, and 2 over 3 is 0.6666, right? Very good. Go home, try to fill in these values, but we see that here in the graph. So those values at 0.9999, it will be 0.500025. If x come closer and closer to 1 from the left-hand side, then f of x will come closer and closer to 0.5 from where? We're not done yet. If x comes from the left side of 1, then f of x will be coming down from here, right? And if x goes from the right side of 1, it will goes up here, right? In this direction. Anyways, what is the limit of this function here? 0.5, very good. So the limit of this function is 0.5, even though that f at, oh yeah, that's fine. Even though that the f at 1 is undefined, right? I think we can stop here and I'll see you tomorrow. Try your best to create a WebAssign account